Hello, my dear friends. Welcome to our second lesson on solving simultaneous equations using substitution method. So let's start by looking at this question here. So we are told to solve using substitution method this particular simultaneous equation. So our first step is simply to break down this equation into a linear form, that is by eliminating fractions on either sides of the equation. So let me just rewrite our first equation here. So the first equation was 3y minus 2x over 15, then plus 2x plus 1 over 3 is equals to 2. So the first step is to eliminate the fraction, that is by multiplying each and every term by the LCM. So the LCM of 15 and 3, of course, is 15. So I'll multiply this term by 15, I multiply this term also by 15, this term also by 15. So that 15 and 15 will cancel out. So this will remain to be 3y minus 2x, then plus. So 3 goes into 3 goes into 15 5 times. But remember, the 5 is supposed to multiply each and every term on this particular fraction that we had here, or each and every term on the numerator. So that to do that, I'll simply take 5 into bracket 2x plus 1, because 5 should multiply each and every term on the numerator. Then 2 multiplied by 15, I'll get 30. So I can open this bracket so that I have 3y minus 2x, then plus 5 times 2, I'll get 10. So this is 10x, then plus 5 times 1, I'll get 5 is equals to 30. Then I collect the like terms. Then so I'll start by y, so that I have 3y. Then negative 2x plus 10x, I'll get positive 8x. Then I take 5 towards the right hand side. So if 5 crosses the equal sign, I'll have 30 minus 5, which will give me 25. So this is equals to 30 minus 5. So this is 3y, then plus 8x being equal to 25. So I'll name this one as my first equation, or equation Roman 1. Then I also break down the second equation into a linear way by eliminating the fractions. So the equation was, so I had the equation as 2x minus 3y over 15, then minus 1 minus x over 3 is equals to positive 3. So again, I multiply each and every term by the LCM so that I eliminate the fraction. So I'll multiply this term by 15, I multiply the second term by 15, I multiply the third term by 15, because the LCM of 3 and 15 is also 15. So 15 into 15, they will just cancel out, so that I remain with 2x minus 3y, then 3 into 3 into 15, 5. But remember again, this 5 should pre-multiply each and every term on this numerator. So I'll combine 5 with the sign, that is pre-multiplying my numerator here. So 5 times negative, I'll get negative 5. But because negative and 5 are supposed to pre-multiply each and every term on this particular numerator here, I'll use brackets. So I'll have negative 5 into 1 minus x being equal to 3 by 15, I'll simply get 45. Then I can open the bracket, so I'll have 2x minus 3y, then 5 times 1, I'll get negative 5. Negative 5 times negative x, negative times negative will give me a positive. 5 times x, I'll get positive 5x being equal to 45. Then I can also choose to collect the like terms, starting maybe with y. So I'll have negative 3y, then the x, I have 2x and also 5x. So 5 plus 2, I'll simply get positive 7x. Then the other term, I'll take it to the right hand side, that is the term that is having a constant. So this will be equal to 45, then of course my plus 5, because when 5 crosses equal sign, it becomes a positive. So that I have negative 3x, then plus negative 3y, then plus 7x being equal to 50. So that will give me 50. So I can simply rewrite the equation choosing to start with x, or I can also just leave it in that particular format. So this becomes my second equation. Now, once we have the two linear equations, we can now solve them simultaneously using our elimination method. So let me just rewrite the two equations that I have. So I have 3y plus 8x being equal to 25 as my first equation. Then I have negative 3y plus 7x being equal to 50 as my equation Roman 2. So if I look at the two equations, let me start by making y the subject of the formula that is in equation Roman 1. So I'll simply say making y subject of the formula, making y subject of the formula in equation 1, making y subject of the formula in equation 1. So my equation 1 was 3y plus 8x is equals to 25. So if I want to make y the subject, first of all, I'll leave the term that has y on the other side so that it's just alone. So I'll take a positive 8x to the right hand side so that I remain with 3y being equal to 25, then of course minus 8x, because when 8x crosses the equal sign, it becomes a negative. So to remain with y, I simply divide both sides by 3 so that I have y being equal to 25 minus 8x over 3. So I'll label this one as my equation Roman 3. Then because I've used equation Roman 1 to make y the subject, I'll simply substitute these in the equation that I've not used. That is in my equation Roman 2, because I've not used it anywhere. So I'll simply say substituting y is equals to 25 minus 8x over 3 in equation, substituting that in equation Roman 2, I'll have the following. So let me just rewrite my equation Roman 2. My equation Roman 2 was actually, this was my equation Roman 2. My equation Roman 2 was negative 3y, then plus 7x is equals to 50. This was my equation Roman 2. So in the place where I have y, in the equation Roman 2, I'll be substituting with 25 minus 8x over 3. So this equation will become, I'll have negative 3 into y. But what is my y? My y is 25 minus 8x over 3. So I'll have negative 3 into my y is 25, that is minus 8x over 3. 25 minus 8x over 3. Then I continue with my equation, plus 7x is equals to 50. Plus 7x is equals to 50. So remember, this one means I can simply decide to, so this one is just the same as saying negative 3 into 25 over 3, then minus 8x over 3, then plus 7x is equals to 50. That is, each and every term can be on its own denominator. Then if I open the bracket, negative 3 will pre-multiply each and every term within the bracket so that I have negative 3 multiplied by 25 over 3, then negative 3 multiplied by negative 8x over 3, then plus 7x is equals to 50. So again, this will be, so 3 into 3, 1, 3 into negative 3, I'll get negative 1. So negative 1 times 25, I'll simply obtain negative 25. Then 3 into 3, 1, 3 into negative 3, I'll get negative 1. Negative 1 times negative 8x, I'll get a positive 8x, then plus 7x is equals to 50. Then of course, I can also collect the like terms by taking negative 25 towards the right hand side. So I'll remain with 8x plus 7x being equal to 50. When negative 25 crosses equal sign, it becomes a positive 25. Positive 25. So 8x plus 7x, I'll simply get 15x being equal to 50 plus 25, I'll simply get 75. I'll get 75. Then I divide both sides by 15 so that I make x the subject. So x will be given by 75 over 15. So I can simplify this. I can have 5 goes into 15 3 times. 5 goes into 75 25 times. Because 5 into 7, that is, no, sorry, this should be, I think it should be 15. So 5 goes into 7 one time, remainder 2. So 7 into 25, 5 times. Then 3 into 3, 1, 3 into 15, it goes there 5 times. Therefore, my x will be equal to positive 5. So to solve for y, I just come back to my equation Roman 3. So I just simply substitute the value of x in equation Roman 3. So equation Roman 3 was, so we can just say from equation Roman 3 was y is equals to 25 minus 8x divided by 3. That was my equation Roman 3. So if I substitute, so substituting x is equals to 5 in equation Roman 3, I'll simply have the following. So my equation Roman 3 is y is equals to 25 minus 8x. But what is x? X is positive 5, then divided by 3. So this will be equal to 25 minus 40, then that is 8 times 5, I get 40, divided by 3. So this will be equal to, if I take 25 minus 40, 25 minus 40, I'll simply get 25 minus 40, I'll simply get negative 15. So this will be negative 15 divided by 3. So again, 3 into 3, 1, 3 into negative 15, I'll simply get negative 5. So that simply implies that y is equals to negative 5. So I'll simply conclude by saying that, therefore, x is equals to positive 5 and y is equals to negative 5. So that is how to behave when you get a question involving fractions. Then lastly, we look at our fourth and last example. So we are told to solve these equations by substitution method. So my first step, let me deal with my first equation. So the first equation, I'm given that 2x divided by x minus 7 is equals to 1. So the first step, I'll simply eliminate the fraction by doing what we call cross multiplication. So 2 times x, that is 2x times 1, I'll simply get 2x times 1 being equal to 1 into x minus 7. That is if I cross multiply. So this is simply 2x is equals to x minus 7 is equals to x minus 7. Then from there, I'll simply collect the like terms. So with the like terms I'm given, I can take x towards this side. So I'll have 2x minus x being equal to negative 7. So this is simply x is equals to negative 7. So actually the first equation is simply over. Then the second equation I have, I'm given 3x to the ratio of y minus 5 being equal to 1 to 2. So the easier way of doing this one simply means 3x over y minus 5 is equals to 1 over 2. So that is what it means. Therefore, I can cross multiply. I'll have 3x multiplied by 2 being equal to 1 multiplied by y minus 5. So this will be simply 6x being equal to y minus 5. But because I already have the value of x here, I'll simply substitute. So I'll say, maybe let this one be equation 1 and this one to be the second equation. So I'll say substituting x is equals to negative 7 in equation Roman 2. I'll have the following. So equation Roman 2 is 6x is equals to y minus 5. So it will simply be 6 into my x is negative 7 into negative 7 is equals to y minus 5. Therefore, so 6 times negative 7, I'll get negative 42 being equal to y minus 5. So I can take 5 towards the left hand side so that I remain with negative 42, then plus 5 being equal to y, being equal to y. Now, if you compute negative 42 plus 5, you'd simply obtain negative 37. So negative 37 is equals to y. Therefore, you can simply conclude that, therefore, x is equals to negative 7 and y is equals to negative 37. Of course, if you have any other topics or any other subtopics that you suggest we should handle through, feel free to notify me through the comment section. This is Kind Tuition Academy. Thank you very, very much for accompanying me until the end of this lesson. I do not take it for granted. Until next time.